Okay, bacho, you have seen that, Bismillahirrahmanirrahim, like you have been seeing if there is something like x cos x, okay, or there is something like maybe sine x e raised to power x, or there can be x plus 1, and then there is secant square x dx. So we have the products over here, okay? Or later on you will see that using this integration by parts we'll be able to integrate something like let's say there is ln x, okay, or maybe sine inverse of x kind of things. So to understand this integration of parts, you will have to go back to the u dot v formula. When you have d by dx of u dot v, so this is basically u v dash plus v u dash, okay? So when I cross multiply this, this becomes d of u dot v, that is u v dash dx plus vu dash dx. So we integrate both the sides like this, okay? So I'll keep just one of them over here and I'll move the other to the other side. So we normally keep this one to this side, okay? So this is going to be integral of uv dash. Now you see that these are cancelled and you're only left with the uv over here. uv minus integral of, I'll be writing it as u dash v dx. Now this is the formula, or this is the technique when you have to perform integration by parts. Now look at this very carefully. This is u v dash. Now when you have u and you differentiate this, after the differentiation, this becomes u dash. And how can this u dash become u? You will have to integrate it, okay? Similarly, when you have v, after its differentiation, this becomes v dash. And when you want to go back from v dash to v, you basically integrate this. So you can see that you have u over here. This u is as it is here, but here you have u dash. So that means whatever is u over here, that will be differentiated in this term. And this is your v dash. So v dash becomes v after the integration. So this is going to be the integral of this term over here in both of these two terms, okay? Now let me do an example over here. Now suppose you have to integrate x cos x. Now this x cos x, this is clearly a product and there is no direct way of integrating this. So you have to assume that this is your u and this is your v dash, okay? We keep the term that we keep as u, that is basically the term that can be eliminated through the differentiation. Now you see that this cos x can be differentiated, or this can be integrated infinite times. Like if you start differentiating, this will keep on changing between cos x and sin x. But this will simply be eliminated in the very first derivative, okay? So u is normally kept, the one which can be eliminated through the differentiation. So while choosing your u and v dash, you have to keep this thing in your mind, okay? So now this u as it is over here, and you have to write its integral because this cos x is your v dash. So you will write here sine x. The integral of cos x is sine x. Now minus, now you have to put all this integration sign because this is a long method. Now u dash, so u is x, so its u dash is going to be 1. Though we don't need to write 1 here, but I'm still just writing is it so that you remember this, that where did this 1 come from. And then again Cos x integral is going to be sin x. So please look at this. This is u, this is your v, like the integral of this cos x. And your u dash is 1, and your v is this sin x. Okay? So this is never completed in just one step. So you just neat it up. This becomes x sin x. Okay? And then you have left here minus integral of sin x. Okay? And finally, you can say that this is going to be x sine x. And when you integrate this, this is going to be plus cos x and then plus c. So this is the integration by parts, very simplest explanation. And then you can apply this to maybe sine x e raised to x. Like there are further, like, extensions of it. There are, like, more difficult situations. Now suppose you have to integrate, let's say there's x squared plus 1, and you have e raised to power 2x. Okay, so you should write that formula on the side so that you remember that what has to be done. So this is basically uv dash dx, and this is uv minus u dash v dx. And remember, you have got it by the reverse of that u dot v method in differentiation. So if you if you want to practice this in a bit slower way, so you can say that, okay, now this is my u. Okay, like you can, on your side notes, you say, okay, my u is x squared plus 1, and my v dash is my v dash is e raised to power 2x. So I'll be needing u dash, so that will be 2x, and I'll be needing just the v, so v will be e raised to power 2x over 2. Okay, now let's put these values here. So u is going to be coming as it is, x squared plus 1, and then the integral of this v dash, that is e raised to power 2x over 2 minus, now I have to write the u dash over here, which is going to be 2x times this e raised to power 2x over 2. Okay, normally we say that this u is a very sharif admi. This simply like, goes away to the differentiation, but this one is a badmash one, so we keep on doing its chitro, like yahan pe bhi you integrate this and you integrate this here as well, and this will be integrated once again. Anyhow, so just neating it but a bit, this 2 is cancelled with this 2, so we write this as half into x squared plus 1, and this is e raised to power 2x, and this is x e raised to power 2x. Now if you look inside here, there is still a product, so you will perform that integration by parts once again on it. Okay, so this is going to be half into x squared plus 1 e raised to power 2x, and then I should use the brackets here, square brackets. So this is my u, this is my v dash. So this x e raised to power 2x over 2. So u comes as it is, and it is going to be the integral of this e raised to power 2x minus, now the derivative of this, that is going to be 1. And again, its integral is going to be e raised to power 2x over 2 dx. Remember, whenever you put this integration sign, you have to write the dx or whatever, like with respect to what you're doing that integration, you have to mention that. Okay, so this is, let's make it simplify this a bit. This is x squared plus 1 e raised to power 2x, and this is going to be minus half x e raised to power 2x, and this one is going to be plus half there is still some integration to be done here. You see that this is such a long method here. Now this is going to be, now since we don't have any more product here, Okay, so this can be directly integrated. This is half x squared plus 1. This is e raised to power 2x minus half x e raised to power 2x. And this will be 1 over 4 e raised to power 2x then plus c. Any question?
Sir, the method is easy. I mean, method की वजह से easy लग रहा है, but I feel like ये maths level और further maths के questions ज़्यादा खतरनाक होंगे.
Obviously, you should always be looking forward to that, Zenia. बिल्कुल ऐसे ही है. Okay. वहां पे तो, do you know, you will have to do that n times.